When a 15-foot wave crashes onto a beach, it releases energy that could be harnessed to generate electricity. That's why these Scottish scientists are studying the energy that ocean waves carry. One of their laboratories is a rectangular wave tank. The more fluid in the container, the more pressure there is on the fluid at the bottom, and the faster it will flow out. That's because gravity pulls the fluid down. That is, as the tank empties, the amount and therefore the weight of fluid goes down. The pressure of the fluid at the hole in the bottom decreases, so the rate the liquid flows out changes over time. Let's suppose the scientists need to drain this huge tank, and they want to know how long it will take. Suppose the engineers have provided this function for volume remaining in gallons. The amount of fluid left is a function of time in minutes after the draining starts, including the square of the time, expressed in a quadratic polynomial. V is volume and T is time. You can see that at time 0, the first two terms drop out as zeros, giving the full capacity of 40,000 gallons, the starting amount. To get the emptying time, we're looking for the value of T at which the volume in the tank, V, reaches 0, a root of the function. A root is a value of the variable that makes the value of a function 0. Since this is a quadratic equation, one way to figure out a root, or roots, is to use the general quadratic formula, which provides roots of quadratic equations. It's derived by solving the general quadratic equation for x when the value of the quadratic expression is 0. This is the quadratic formula. From the engineers, these are the values for A, B, and C in the expression for the volume of water in the emptying tank. C is 40,000, the number of gallons of water in the tank. Substitute these values into the quadratic formula and you get the root, or roots. So T equals about 120 plus or minus 0. And the time for emptying the tank is about 120 minutes, or 2 hours. The discriminant, the part under the square root sign, is 0. When the discriminant equals 0, the equation has only a single root. This is reflected in a graph that touches the x-axis at one point, as does the one for this equation. Here, the root is 120, meaning the tank empties in 120 minutes or 2 hours. If the discriminant were positive, there would be two roots, one adding and one subtracting the radical part of the formula. And if the discriminant were negative, there would be no real roots. These surges of water may someday turn out to be a great source of renewable, cheap, and clean energy.